All right, Vince, here we go. Sorry I couldn't fit you in here, but I think got a outstanding movie for you here. Okay, so you were asking about this one. What is the domain of this, the composite function? So with the composite function, it's a little weird, but I've got you. Okay, so let me get that going. Okay, so um, you were talking about g of f of x. So g of f of x, that's going to be the composite function. But before we do that, I want to talk about these functions. So we have f of x equals square root of x plus 5. And then g of x equals x squared. So the kind of confusing thing is one of these, the domain of one of these does not matter. Okay, the domain before we begin is what I mean. So the domain of the outside function does not matter, and that is because it's going to change, right? It's no longer going to be x squared. It's going to be something else squared. Okay. Now, f of x isn't changing. It's going on in there, right? We're going to plug that bad boy right in there. So it does matter. So immediately we know we cannot take or find the square root of a negative number. So this has to be greater than or 0. So right away we're going to say greater than or equal to -5. Now, we still need to plug it in just to see if anything bad's going to happen. So g of f of x would equal the square root of x plus 5. I don't know why I put that in parentheses, but it's squared, right? And I think I might see your confusion here because once I square that, um, the square root goes away, right? And all we have is x plus 5. And I think maybe you would put negative infinity to infinity, and maybe it's because of this. Um, and if x plus 5 was the original function, there was nothing else. The domain of x plus 5 is indeed negative infinity to infinity. There's no restrictions on x there. However, because it came from f of x, this is still in play, right? So x must be greater than or equal to -5, which means what are we going to have? We'll have what? -5 to infinity as the domain of the composite function. Okay, so let's go the other way around and see what happens. So let me get rid of that. See how well I can do here without messing anything up. Okay, so now we'll find f of g of x and see how that works. I think you already did that, but I think it's still worth talking about f of g of x. So what's going inside? Well, x squared's going inside. There's no restriction on x squared, right? And so there's nothing that we have to worry about. F is the outside function, so for the time being, we don't have to worry about it, right? So f of g of x would be the square root of x squared plus 5, right? And so looking at that, we know that um, we cannot take the square root of a negative number. However, we do not even have to worry about it because x is going to be squared, right? It's going to be squared prior to us taking the square root. Any number in the real number system, that is, any number on the number line, when it is squared, um, will be positive. So we'll have a positive, we're adding a positive, we're always going to be able to take the square root of it. You can even say, x squared, if you wanted to, plus 5 must be greater than or equal to 0. X squared must be greater than or equal to -5, but we can't solve for x because the square root of a negative number doesn't exist, which also means there is no restriction. Okay, then you had this one. It's important here to understand that this is not a composite function. This is just um, one function divided by another. And since they are coming from the, they're coming from two different functions, we must consider the domains of both functions before we do our thing, right? So f of x is equal to 6 over x, and g of x is equal to 9 over x squared minus 1. Now, for both of them, we have restrictions on their individual domains. X cannot equal 0 for f of x here, and I'm going to work over here. X squared minus 1 cannot equal 0. We 0 there. We add 1 to both sides. X squared cannot equal positive 1, so x cannot equal plus or minus 1. Okay, those do not go away. This is not a composite function. We're just taking f and we're dividing it by g. Okay, so f of g, or f over g of x would indeed equal 6 over x over, what do we got? 9 over x squared minus 1. And we multiply by the reciprocal, so that's 6 over x times x squared minus 1 all over 9. Okay, let me keep it up here. And so we have 6 times x squared minus 1 over 9x. Forgot the equal sign. We could leave it like that. I think you distributed the 6, doesn't matter. I'm going to simplify. 6 over 9 can be 2 over 3. That's what we would normally do. So we end up with 2x squared minus 1 over 3x. Okay. Now here, after we've simplified it with this finished function, the only restriction would be x cannot equal 0. And if I was only given this function by itself, that would be the only restriction. But since it came from this thing, we have to consider the domains of both of them. And again, we have to consider both of them because it's not a composite function. We're not putting one in the other, we're using both. So not only can x not equal 0, x cannot equal plus or minus 1 from the beginning again. So if we had to write it all out, it would be what? Negative infinity until negative 1, union, negative 1 to 0. This is going to be a long one. Union 0 to positive 1, union positive 1 to infinity. So that would be it for that one. Okay. Then I found a couple other examples here. This is similar. Well, no, it's kind of similar to. Well, no, it's not at all because we didn't do a composite function. I was going to say it's similar to this guy, but this isn't composite. I'm going to have us do a composite function here. Okay, so we're going to go neon. What? Okay, come on, Dave. All right, sorry about that. So let's do f of g of x. So again, the outside function, f of x, does not matter. It does not matter because it's going to change, okay? So we're not going to worry about that domain just yet. Now for this one, x cannot equal 0. So that never goes away because we're building the new function using it. Like g of x is the building block of the function. That's like, you know, the cement or something that we're mixing to put in the building. That's a pretty bad analogy, but we do what we can. All right, so now this becomes 4 over 1 over x plus 2, and it's still apparent that x can't equal 0. It's still a fraction here. No matter where a fraction appears, the denominator cannot equal 0. Okay, so we could act. So now we're still going to have a restriction on the domain because I have another denominator, but I'm going to clean it up first. A couple of things we could do here, but I'm just going to go ahead and Make this one big happy fraction so that the denominator is x. So with 2, I'm going to multiply it by x over x. Remember, that's 2 over 1. So this becomes 4 over 1 over x plus 2x over x, which would be 4 over 1 plus 2x over x, which we would then multiply by the reciprocal, multiply 4 by the reciprocal, so that would be times x over 1 plus 2x. Maybe slap a 1 over or a 1 under that 4 just to remind us what's going on. And so this becomes 4x over 1 times 1 plus 2x, right? So when we're done with the composite, we do have to take a look at it and see if there's any further restrictions, if we have a square root or if we have a fraction. And we indeed have a fraction. So the denominator cannot equal 0. So 1 plus 2x cannot equal 0. Solving for that, 2x cannot equal what? Negative 1. X cannot equal negative 1/2. So the domain of the composite must include that and this. So off we go, negative infinity to negative 1/2, union 0 to infinity. Okay. Now I just want to talk real quick about something just in case your teachers bring it up. Like there's another way to get this. I hate it. Okay. I hate it because I'd rather just ignore the domain of the outside function and let it play out. Okay. However, there might be a teacher who says, all right, let us consider this domain, and it is that x cannot equal negative 2. However, it's not part of the domain of the composite function. What you can do to find all the pieces of the domain without finding the composite function is find out for what value of g of x, in g of x, will you get negative 2? In other words, will you get any the restriction on the domain of f? And look what happens. So what's happening is 1 over x cannot equal negative 2. Multiply both sides by x when 1 cannot equal negative 2x. And look what happens. Divide by negative 2. You get negative 1/2 cannot equal x, which is exactly what we got here, right? I find that very confusing because this is not part of the restriction on the domain, but it can be used in a confusing way, again, in my opinion, to find all the restrictions on the domain, which would include this and the restriction on the domain of the inside function, the builder, right? The worker bee, the one that's going in and doing all the dirty work, okay? While we have it, let's just do, we did f of g of x, so we'll do g of f of x, and I have one other example as well coming up. I don't want to mess anything up here. I guess I better use my eraser. Patience. Whoa, that's not an eraser. Okay, so here's the eraser, and right there. Okay. All right, we are gonna go purple. That's right, we're going purple. So now we're gonna do g of f of x, right? G of f of x. So all we care about is f of x as far as the domain when we first start off. So x plus 2 cannot equal 0. Oops. I went off the screen there, sorry. I'll do it over here. X plus 2 cannot equal 0, so x cannot equal negative 2. We do not care about 1 over x, right? It's the outside function, so we don't care about it. We do care in after we do the composite if something else happens that would restrict the domain. Okay, so what happens here? So g of f of x, we're plugging f of x into g of x, so that would be 1 over 4 over x plus 2, right? And we don't have anything that we don't already have. We still have a fraction here, and the fraction cannot equal 0, right? So we're going to clean this up. So it's 1 divided by a fraction, so it becomes 1 times the reciprocal of that fraction, x plus 2 over 4, which ends up being 1 times x plus 2 is x plus 2 over 4. The only thing that can't happen with a fraction, the denominator can't be 0. It's always 4. So it's as far as the composite is concerned, the final function, right, doesn't have a restriction. But since it came from its worker b, in this case f of x, we have to honor that restriction on the domain. So the domain of the composite would indeed be negative infinity to negative 2, union negative 2 to positive infinity. Even though the final composite function doesn't have any restrictions on the domain, there's still restrictions because of how the composite function was built. And to just to further clarify, if I was just given y equals x plus 2 over 4, there are no restrictions on this domain all by itself, right? Not, ooh, that's a terrible infinity. All by itself, just coming out and, okay, here's a function, y equals x plus 2 over 4. There are no restrictions, right? But again, since this was built from a composite function, we have to honor the restrictions of the worker b, the function that goes inside, and also if there are any after we calculate the composite function. All right, so just one more. I'm hoping this is helping. I think it is. Okay, we're going to go blue. So let's do f of g of x. So g of x is the inside function. And here we see that 4 minus x must be greater than or equal to 0. Negative x must be greater than or equal to negative 4. When we divide by a negative 1 here, we must flip the inequality. So this is definitely part of the domain. X must be less than or equal to 4. All right. So now we're going to pop that bad boy in there. G of x into f of x, so that becomes the square root of 4 minus x squared plus 3. The square root of anything squared is whatever is under there, so that's 4 minus x plus 3 which is equal to 7 minus x. So the final composite function is this. We look, there is no restrictions after we have simplified everything. So our only restriction is that x must be less than or equal to 4, which gives us a domain of negative infinity to 4 inclusive, since 4 can be included. Again, even though there are no restrictions on the final answer, we must honor the restrictions on the worker b, okay? And I haven't done the reverse, but let's just see what happens, see if there's any restrictions. Maybe you're getting good enough where you can look ahead and see there's not going to be. So let's do g of f of x, right? G of f of x. All right, so we have to consider f of x. Any restrictions here? And the answer is nope, there certainly isn't. There are no restrictions on this domain, okay? So on the worker b, the one that's going inside. So g of f of x would be equal to the square root, and we're going to replace x with x squared minus 3. So this becomes 4 minus x squared plus 3. And we got to clean that bad boy up, right? So that's the square root of 4 minus x squared plus 3, which is the square root of 1 minus x squared. Now we got to check this bad boy out because it's not, there's a minus in front of that x squared, and if we plug in an x, then excuse me, it could turn out being negative, right? You might be able to look at it and figure out what we can do, but let's go ahead and work with it. So 1 minus x squared must be greater than or equal to 0. Minus x squared must be greater than or equal to -1. We divide both sides. X squared must be less than or equal to +1, right? Divide both sides by a negative, we must flip the inequality, okay? So, the way I like to do this is with a sign diagram, SIGN, not the trig function sign, a sign diagram. So, because I think the inequality is a bit confusing, okay? So what I do is temporarily drop the inequality sign, and I find out where x squared equals 1, okay? Equals 1. Or maybe even I start here. Instead of this greater than or equal to 0, if you wanted to, you could do 1 minus x squared is equal to 0. So then negative x squared equals 1, equals -1, sorry. X squared equals 1. So x could equal plus or minus 1. And it's like, Dave, what the heck are you doing? Well, we just found out what values of x we get 0, right? And if we plug in +1 or -1 here, we get it equal to 0. And we need this in this form after we plug in to be greater than or equal to 0, or here it has to be less than or equal to 1. Doesn't matter, okay? But what we can do is a sign diagram, because in order for a function to be positive or negative, or to change from positive to negative, it must first equal 0, right? So we already have where the function equals 0 right here. So these intervals in here are either going to all be positive or all be negative, okay? So let's just take a look right here, okay? And the way we can, or we'll use, what I should say is we're going to use 1 minus x squared to help us with our sign diagram, okay? So if I have 1 minus x squared, and I do a test point here, I'm gonna have to do something less than -1, so I would choose -2. So I'm just gonna plug in -2 as my test point, and so 1 minus -2 squared, which is equal to 1 minus 4, which is -3, right? Well, is -3, if I end up with -3, is -3 greater than or equal to 0? No, it is not. So that means that we cannot have, it doesn't work, right? We need it to be greater than or equal to 0. And every number to the left of -1 will not work. So now we're going to do a number between -1 and 1. We're going to test. I'm going to choose 0, okay? And if I plug in 0 for x, 1 minus 0 squared is 1 minus 0. Is 1 greater than or equal to 0? Yes, yes. So this is in the domain. It works, meaning it will work for every single number between -1 and 1, okay? And then we'll test the interval to the right of 1. I'm going to, with some test point, it's going to be 2. You could choose 1,000,000 if you wanted to. It doesn't matter. But we're going to test 2. And so is 1 minus x squared greater than or equal to 0? 2 squared is 4, minus 4 is greater than 0. Is -3, oops, I ran out of space, sorry. Is -3 greater than or equal to 0? It is not. So since that is not true, it can't be part of the domain. So in this case, probably the most complicated one that you will encounter, the domain would be -1 to 1, and -1 is included because of the equal part. We can have it equal to 0. So the domain of this would be -1 to +1 inclusive. All right. Hope that helps, Vince, and we'll see you soon.